All right, so we're going to talk about something called the rate of change of a function. Now, the rate of change is how one quantity changes compared to another. You already have some experience with the rate of change with regard to linear functions. The rate of change of a linear function is just its slope. Remember, the slope tells me how the y values in the top change compared to how the x values change in the bottom. That's called rate of change. It's a comparison. It's also called a ratio. So what we're asked to do in this particular problem is these table of values represents a linear function. This equation represents a linear function. They are different. We want to know which one has the greater rate of change, meaning which one's changing faster. So here we go. What we're going to do for this one is we're going to actually calculate the slope because we're given points. And remember, for a line, the slope never changes. So it doesn't matter what points you pick. So pick any two. I'm going to pick this one and this one. I have no secrets. I'm not, no mysteries here. I've just picked those. So I'm going to do my change in y's over my change in x's. So my change in my y is 17 minus 9. And my change in x is 4 minus 8. So 17 minus 9 is 8. 4 minus 8 is negative 4. The slope is negative 2. And then over here, this is my slope-intercept form. My y equals mx plus b. So always the slope is in front of the x. So the slope is negative 3. So now we're going to compare those two quantities, and we're going to see which one is the greater rate of change. And so when I do this, when I compare negative 2 and negative 3, which number is greater? Now don't be fooled. They're both negative, and I know the temptation is to say negative 3 is bigger because it has a bigger value, but remember, the negative 3 is more negative. So negative 2 is actually bigger than negative 3. So which one of these two functions has the greater rate of change? That would be this one that we had to calculate the slope of.